I'm going to solve this linear system by elimination. 2/3 x plus 1/5 y equals -2. I'll call equation 1. 1/3 x minus 1/2 y equals -7. I'll call equation 2. I'm going to start off by eliminating the fractional coefficients in both equations. To do this, I'm first going to determine the least common multiple, or LCM, of the denominators in each equation. In equation 1, I have denominator 3, denominator 5, and denominator 1. The least common multiple, or LCM, of these three denominators is 15. In equation 2, I have denominator 3, denominator 2, and denominator 1. The least common multiple, or LCM, of these three denominators is 6. Now I'm going to multiply each equation by the corresponding LCM that I just determined. In other words, I'm going to multiply equation 1 by 15, and I'm going to multiply equation 2 by 6. So equation 1 gets multiplied by 15. All three terms get multiplied by 15. So I'm going to have 15 times 2/3 x plus 15 times 1/5 y equals 15 times -2. 15 times 2/3 x is 10x, plus 15 times 1/5 y is 3y, equals 15 times -2 is -30. So I get 10x plus 3y equals -30. This equation will be equivalent to equation number 1. The second equation is multiplied by 6. All three terms get multiplied by 6. So I'll get 6 times 1/3 x minus 6 times 1/2 y equals 6 times -7. 6 times 1/3 x is 2x minus 6 times 1/2 y is 3y equals 6 times -7 is -42. So I'll get 2x minus 3y equals -42. This equation will be equivalent to equation number 2. So I have 10x plus 3y equals -30, and 2x minus 3y equals -42. I'll call this one equation 3, and I'll call this one equation 4. Now I notice right away that in equation 3 and 4, the y terms have opposite coefficients. In other words, I have a 3 here and a -3 here. So right away, I can add equations 3 and 4, and the y terms will be eliminated. So I'm going to add equations 3 and 4. 10x plus 2x is 12x. The y terms will add to give 0. -30 plus -42 is -72. So I get 12x plus 0 equals -72. 12x plus 0 is just 12x on the left-hand side, and I've got -72 on the right-hand side. To get x by itself, because this means 12 times x, I'm going to divide the left-hand side by 12. But if I divide the left-hand side by 12, I must also divide the right-hand side by 12. 12 divided by 12 is 1, and 1 times x is just going to be x on the left-hand side. -72 divided by 12 is -6. So I get x equals -6. Now I can substitute x equals -6 into either equation and solve for y. I'm going to substitute x equals -6 into equation 3. 10x plus 3y equals -30. So where I see x, I'm going to substitute in -6. So I'll get 10 times -6 plus 3y equals -30. 10 times -6 is -60. So on the left-hand side, I'll have -60 plus 3y equals, on the right-hand side, -30. I want to get y by itself on the left-hand side. So the first thing I'm going to do here is I'm going to add 60 to the left-hand side. But if I add 60 to the left-hand side, I must also add 60 to the right-hand side. -60 plus 60 is 0, so I'll have 0 plus 3y, which is just 3y on the left-hand side. And -30 plus 60 is 30. So I get 3y equals 30. 3y means 3 times y. So to get y by itself on the left-hand side, I'm going to divide the left-hand side by 3. But because I divide the left-hand side by 3, I must divide the right-hand side by 3. 3 divided by 3 is 1, and 1 times y is just going to be y on the left-hand side. And 30 divided by 3 is 10 on the right-hand side. So I get y equals 10. So the solution to this system is x equals negative 6, y equals 10.